Hello students, welcome to Smart Engineering Tutorials. A very happy new year to all the students out there. Today, I'll be discussing some facts about Huffman Coding. In my previous video of Huffman Coding, I got many queries and confusions among students about that method. For that reason, I have compared that method with one another method of doing Huffman coding, and then I have compared that which method is best and why. So there are many books from which you can study, like Sing and Sapre, Simon Haken's B.P. Lati, Top Shelling, George Kennedy. My previous lecture of Huffman coding, I prepared it from Sing and Sapre, and today's lecture is prepared from Simon Haken's. So Simon Haken's has put some light on some key issues of Huffman coding, which I'll be covering today. So I have compared basically both the methods, and at the end of the video you'll see that which method you should opt while doing the question and why, with the answer to it. So let's start. Huffman encoding process is not unique. There can be made two variations in the process, and these two variations are responsible for the non-uniqueness of the Huffman code. The first variation says that at each splitting stage means in Huffman coding, when we arrange the probabilities of the symbols in decreasing order, the last two symbols or the last two messages, their probabilities are added. So that is called as the splitting stage. So at each splitting stage, there is arbitrariness in the way a 0 and 1 are assigned to the last two source symbols or the messages. Like in my previous video, I used to write 1 and 0 for the last two messages, whereas Simon Haken's uses 0 and 1. So this creates one variation, that some use 0 and 1 and the other uses 1 and 0. So next point says that whichever way the assignments are made, whether you are using 0 and 1 or you are using 1 and 0, they both, however, resulting differences are trivial. It means that whether you use any of the assignment schemes, like I used 1 and 0 in my previous video, or today I am going to use 0 and 1 also in one method. So if I use both, the difference by this assignment is trivial, means it hardly matters which assignment scheme you are using. Now, the second variation arises when, ambiguity arises when the probability of a combined symbol is equal to another probability in the list. It means that when you add the probabilities of the last two messages, and if the resulting sum is the same as the probability of a message which is of equal value, in that case, where should we put or where should we place the added probability? Either above the existing value of the probability or below. It depends where we have to put. Like here, we may place the probability of the new symbol. It means new symbol means the added value of the probability. It will be very clear from the numerical. We may place the probability of the new symbol as high as possible. Means if the sum is the same as the probability value of another symbol, in that case the sum can be placed on top of the value of the probability which is of the same value. in the question as high as possible, or I can place the added value of the probability below the same value probability in the question, or as low as possible. It will be very clear from the question. Now, the next point says that whichever way is used, whether you are going to put it above the same valued probability or below it, it should be consistently adhered or followed throughout the encoding process. Any one you choose, whether you opt for putting it on top of the value or below the value, whichever you are going to use, just stick to that method or stick to that rule throughout your encoding process. Because I'm telling you this because we'll be seeing in both the methods, I'll be using both the different methods and then I'll be comparing that which one is better. Now, when the added value of the probability is placed on top or below, in these two cases, the difference arises. And where this difference arises? It arises in the length of the code words. So the individual code word lengths will be different when we opt for these two different methods. Although the average code word length, that is the L bar, it remains the same. What differs? The individual code word lengths. Now since the average code word length is the same, but the individual code word lengths are different, so when these two methods are used and when L bar is same for both, so how to compare that which one is better? For that purpose, we use another parameter, that is the variance. So to compare the different lengths of code words for the same symbol of message, because if you opt these two different methods, then the same message will have different code words in both the methods. So to compare, what we'll do, we use variance of the average code word length L bar over the and symbol of source symbols or messages as. So what we will do, for both the methods, we will calculate the variance sigma square, and the formula for sigma square or the variance is summation k is equals to 0 to k minus 1. Since here this minimum value of k is, I have put it here 0 because the question suffix starts from S0. If it starts from 1, you can put here 1. The basic purpose of this is to sum up all the messages. And what parameters are summed up? The product of pk, this is the probability of the message k, into lk minus L bar whole square. This lk is the length of code word of symbol sk. This L bar is the average code word length. So now we'll be comparing both the methods. One method, that is the method number 1, which is the one which I used in my previous video of Huffman Coding, and method 2 will be the one which I'll be introducing today, and then we'll compare both the method 1 and 2, and then we'll see which one is better. So here is the question. I have a set of messages S0, S1, S2, S3, S4, and their corresponding probabilities set is S0 probability 0.4, S1 0.2, S2 0.2, 0.1, 0.1, and so on. So I have this is the set of probabilities and this is a set of messages, and the probabilities, corresponding probabilities written just below the message. So the first step of this Huffman coding is to write the messages in the decreasing order of probabilities, but as we can see here, all the messages are already written in the decreasing order of probabilities, so no need to do this step, it is already in the decreasing order. So S0, S1, S2, S3, S4, and 0.4, 0.2, 0.2, 0.1, 0.1 till here symbols and then probabilities, corresponding probabilities. The first step is that the last two symbols or the messages are combined. And here in my previous video I used 1 and 0. It hardly matters whether you put 1 or 0 here or 0 and 1 here. It will make no difference on the code word length or on its efficiency. You can check it. There is no difference. I'll show you. So I have combined last two message. So probabilities are 0.1 and 0.1. So 0.1 plus 0.1 is 0.2. And the symbols which I have designated to them is 0 and 1. So 0.2, this new 0.2, where will I place them? There are two methods. One is whether I can put this 0.2 as low as possible, and the other is as high as possible. See, in the question we already have 0.2 and 0.2 values, and the sum is also coming as 0.2. So this 0.2 can either be put as low as possible, means at the end of all the 0.2s occurring in the question, or as high as possible, means on top of all the 0.2s in the question, that is here. But in this method number 1, I am going to put the new 0.2 sum as low as possible, that is at the end of the 0.2 which are in the question. So this 0.2 and 0.2, so at the end the new 0.2 comes. At the as low as possible I am taking the condition. So I place it here. Then this is the first reduction, and now I am going to add again the last two messages. I am going to give them assignments of 0 and 1, and their sum is 0.4. Now since I am using the method 1 in which I am going to put the sum, if it has the same value as in the question, then I'll be putting this sum as low as possible. So the sum is 0.4, and in the question I already have 0.4. So I'll not disturb the position of this 0.4. I'll just put this new 0.4 below, means as low as possible, below that of 0.4. Since I have to arrange all the probabilities in decreasing order, this thing means where you have to put above or below, this ambiguity comes only when the sum is of same value as occurring in the question. Since it means that if the sum is having the same value as of the probability of a message in the question. If it is not the same, then you have to keep it in the decreasing order wherever it comes in the order. So 0.2, 0.2, 0.4. So this 0.4 will come below the existing 0.4, and this 0.2. Now in the next stage I am going to combine these last two again. I'll give this 0, I'll give this 1, and this 0.4, 0.2 I'll add their probabilities. It comes 0.6. So no problem, since 0.6 has to be arranged in the decreasing order, and 0.6 is greater than 0.4, so it will come at the top. 0.6 and this 0.4. What I do in my technique is that whether I put as high as possible or as low as possible, I don't disturb the order of the probabilities. Like here, if I am writing here 0.4, then 0.4 will come in the same line. I don't disturb, because I either put the values in between the spaces. I don't change the order, because when you'll have to write the codes, then you'll have to move backwards. So don't change the order, so that it is easy for you to write the code and move in a straight line. In Simon-Hackers, they show that they are writing in a slope, but I don't prefer that to make things easy. And in the last stage, I combine them. No need to combine, because two symbols are only left. You have to assign them code, so give them 0 and 1. So now no symbol is left without a code. And this is the last reduction, that is reduction number 3, or we say that third reduction. So now if you see here 0.4, the order you can match. I haven't changed any order. This will help you in writing code word. Now you have to write the code words, and for writing the code word, what you have to do, you have to move. If you are going to move, then you have to write the code in backward direction. It means, like, if I want to write the code for S0, I have just placed all the symbols here. I have placed the probabilities corresponding values here, and then I'm going to write the code one and its length here. So for S0, if I see for S0, I'll move from first stage where I had written the probability 0.4. 0.4, no assignment of 0 and 1s. 0.4, 0.4. The first assignment comes, this 0.4 has got 1. So this one, since there is only one bit, you can consider is at LSB or MSB, since there is only one bit. So for S0, I got a code 1. Now for code S1, 0.2, no assignment till now. Here 0.2 has got 1. So this 1, whichever bit you are getting, you just start writing it as in backward direction. Means the first bit is not the LSB. You can write it as, see, 0.2, you have got 1, then this 0.2 has moved after combining and it has formed 0.6, you have got 0. So the code becomes, you will have to write in backward direction. It becomes 0, 1. How 0, 1? Because you got 1 first. You have got 1 first, so it will become the last bit. So I have put 1 at the back, and then this 0.2 has moved after combining into 0.6 and it has got 0. So 0 will come front. So it means that in the order in which you are moving from left to right, when you're moving from left to right, then whatever bit you are getting, you write in the opposite order. Means the first bit which you get from left to right, you make it the last bit. Means you make it as the LSB. And as you keep on moving, the last bit which you obtain from left to right, it becomes the MSB. As I have got here, I got for S1, I got 1 first, so it forms the LSB, and I got 0 at the last, so it forms the MSB. So this, just keep this in mind, that when we move from left to right, whatever bits we are getting, we have to write it starting from LSB. The first bit you get is the LSB from left to right, and at the last, the bit you get, it becomes the MSB. So in the order in which you get the bits, you write in the opposite order. Now the code word for S2, 0.2, it has got 0 assignment here. So this 0 becomes the LSB. Then this 0.2 has moved further after combining into 0.4 and it has got 0 assignment, and this 0.4 after combining forms 0.6 and it has also got 0 assignment. So it is a code 0, 0, 0. Now for S3, this 0.1 is got 0, this forms the LSB. This combines to form 0.2 and it has got 1 assignment. After combining, it forms 0.4, it has got 0, and this 0.4 has, after combining, moves to 0.6, so it has also got 0. So this 0 becomes the MSB. So 0, 0, 1, 0 for S3. Now for S4, it is 0.1, so it has got 1 assignment. After moving, it goes to 0.2, 1 assignment, goes to 0.4, 0 assignment, and it goes to 0.60 cents. So this 0 is the MSB. So in this way we have got all the 5 codes for the 5 symbols. In the length column you can write there lengths 1, 2, 3, 4 and 4. And now you can calculate the L bar, which is the average length code, average length of the code, and you know the formula for that, summation k from 0 to 4, since S has a suffix from 0 to 4, and summation of pk to pk into lk. Lk is the length of the code. So here pk and into lk will be added up for all the 5 messages, and we'll obtain for it as 0.4 into 1 plus 0.2 into 2. Actually I'm multiplying probability into the length and then adding these products for all the 5 messages, plus 0.2 into 3 plus 0.1 into 4 plus 0.1 into 4. So I have added up all, and when you add up all these numbers, then you get the value of L bar as 2.2. So this is one method in which I have placed the sum of the probability as low as possible. So this is the method which I used in my previous video of Huffman coding. So here I have calculated L bar. I have got 2.2, and now I'm going to move to method number 2, in which I'll be placing the sum as high as possible. One more thing which I would like to clear here itself is that in this same very method, see, if you put 1 or 0, 1, 0, 1, 0, 1, 0, it hardly makes any difference on the length of the code. Since the length of the code will be the same, the only difference is that wherever I have written 1, 0 will be written. Where 0 is written, 1 will be written. But the length of the code will not be affected. So it hardly matters whether you write 0, 1 or 1, 0. Now in method number 2, we are going to place the sum of the probability of the last 2 symbols. If it happens to be the same number as in the question, then we will put here as high as possible. So we'll be seeing through this example. I'll add up, I'll give 0, 1. The sum is 0.2. So here I have got 0.2, and in the question there is 0.2, 0.2 already. There are 2 0.2s. So where I will put these? In this method, my method here is to place this number or this sum 0.2 as high as possible. As high as possible means if there are already values of probabilities of the same number, like 0.2 I have, and there are already 2 0.2s. So this 0.2, sum of 0.2 will go as high as possible, means on top of these 2 0.2s, as high as possible. This is the highest place I can give to this sum, 0.2. I am writing in between 2 lines so that I don't disturb the order of the probabilities. So 0.4, and this new 0.2 will get the highest place, and the 0.2s in the question will come below this 0.2. So first reduction is over. Now second reduction says, again you combine them, assignment of 0 and 1s, and now again I have got 0.4, and already I have 0.4 in the question itself. So 0.4 already existing and new 0.4. So I'll give this new 0.4 as high as possible, means on top of the existing 0.4. Just keep in mind that I'm not changing the order. I put this new 0.4 at top, and this 0.4 no order change. I haven't changed the positions, and this 0.2 comes here. Again, this is the second reduction. Now the third. Again, I'll combine this 0 and 1, and this 0.4 and 0.2, it will get 0.6. And since 0.6 is higher than 0.4, so it will automatically go above 0.4. So 0.6, the third I'll write here. It will create confusion otherwise. Third reduction is here. 0.6, and this has gone here, and this 0.6, and then comes 0.4. This 0.4 is here. And since last two are left, so I'll give them assignment 0 and 1. No further reduction is needed. So I'll now write all the code words. I've already made the table here. I've written the messages. I've written the probabilities. I will write the code word and then the length here. So for symbol or message as 0, I'll write the code word 0.4, no assignment, 0.4, no assignment, 0.4, one assignment of 0, and then after combining it moves to 0.6, again 0. So the first code word is 0, 0. Method is the same, that moving from left to right, the first bit you get, it will be the LSB. Like here I have got this 0 first, so it forms the LSB. I'll write in opposite direction, and the last which I have got, it is 0, so it becomes the MSB. For S1, 0.2, 0.2, 0 I have got, it is the LSB. Now after combining it moves to 0.4, no assignment. This 0.4 again here it gets 1. This one is MSB. Now for S2, 0.2, no assignment. Actually this is the probability, so this 0.2 moves to 0.2, it gets the assignment 1, so it is the LSB. This moves after combining to 0.4, no assignment. This 0.4 again moves to 0.4, here 1 assignment, so it becomes 1, 1. So S0, S1, S2, they have got their codes, and S3, 0.1 got 0 assignment, it becomes the LSB. This after combining moves to 0.2, this 0.2 moves here 0.2, it gets 1, and this 0.2 after combining with 0.4 becomes 0.6 and goes to here, and it gets a 0 assignment, it becomes the MSB. So 0, 1, 0. For S4, 0.1 gets 1, it becomes the LSB, moves to 0.2, this 0.2 moves here, gets 1, this 0.2 again combines and forms 0.6 and gets 0 assignment, it becomes the MSB. So 0, 1, 1 for S4. So I'll write the length of the code here, 2, 2, 2, 3, 3. Now just if you want to compare for method 1, length of S0, S0 has length 1 and here it has length 2. S1 length 2, S1 again length 2, S2 has 3, but here S2 has only 2. Here S3 and S4 have 3, 3, but in method number 1, S3 and S4 have 4, 4. So if we compare, then the individual lengths of the symbols or the messages are different in both the methods. So for method number 2, now I'll be calculating the L bar, that is the average length code. I've already written the formula. L bar is summation k from 0 to 4 pk into lk, and it is simple, the sum of the products of the probability into the length. So we have already seen the first probability is 0.4 and the length of first 3 is 2, 2, 2, and the probabilities are 0.4 into and 0.4, 0.2 and 0.2. So if I do the sum, 0.4 into 2 plus 0.2 into 2 plus 0.2 into 2, and the last two symbols have lengths 3 and 3 and the probabilities are 0.1 and 0.1. So plus 0.1 into 3 plus 0.1 into 3. Now if you sum up again these all the values, you will get 2.2 again. So I'll write this value 2.2. So here also the average length is 2.2, and in the previous method also the length was 2.2. So both the methods give the same L bar, and if I calculate the entropy, we know the formula of entropy is summation k equals to 0 to 4. It can be whatever starting and ending values of k are, but actually it is the summation of all the products of pk log to the base 2 1 upon pk. Now see, in this formula of entropy, there is nothing, it has nothing to do with the length of the code. What the things are, or what the parameters are in the question are pk, that is the probability, and log to the base 2 1 upon pk. So there is only the probability which comes into picture in this entropy. So for both the methods, the change is only in the length of the code, so their entropies will be the same because the probabilities haven't changed, they are the same. So if I calculate the entropy using this formula, you can put the values of 0.4, first probability log to the base 2 1 upon 0.4 plus 0.2 log to the base 2 1 upon 0.2 plus again 0.2 log to the base 2 into 1 upon 0.2, and similarly I have two more symbols of 0.1 probability log to the base 2 1 upon 0.1 plus 0.1 log to the base 2 1 upon 0.1. If you try and calculate all these values, then you get the entropy as 2.12193, and this will be same for both the methods. There will be no difference. Now if I talk about the efficiency of both these methods, how we calculate efficiency, eta is equals to Hx, that is the entropy, divided by L bar log m to the base 2, and since there are two symbols, since it is binary 0 and 1, so this reduces to 1, log 2 to the base 2 is 1, so actually the entropy is Hx upon L bar, and since Hx and L bar are both same for both the methods, so we say that in terms of efficiency both the methods are having the same efficiency. So if it say till here, both the methods are equally efficient. They have the same Hx and the same L bar, so they'll give same efficiency. But if I talk about variance, since both the methods are giving different code word lengths for individual messages, in spite of the fact that the average code word length L bar is same. So for this reason, we are going to calculate the variance for both the method 1 and method 2. And variance is actually a measure of the difference between the individual length of the symbols, length of the code of the symbols, and the average length of the code. So we'll see how close these two quantities are. And the closer the quantities means the lesser the value of the variance and better the method. So the method which will have the least value of the variance, that method will be said to be the best, and it will be opted for calculating the Huffman code. So for method number 1, in which we placed the added probability as low as possible, for that method we are going to calculate the variance. And the value which we get here is, since it is again the sum up of product of two things, that is the probability and the difference between Lk minus L bar whole square. So I'll put the values. The first probability is 0.4, and in method number 1, Lk, this L bar is fixed. It is 2.2 for both the methods. The difference is in Lk. So in method number 1, the Lk was of the order 1, 2, 3, 4, 4. So I'll keep this thing in mind. 0.4 into 1 minus 2.2 whole square. The next probability was 0.2 and the length of the code was 2. So 2 minus 2.2 whole square. Then another probability, again it was 0.2 and the code length was 3 minus 2.2 whole square and 0.1 probability, and the length was 4 minus 2.2, that is the average length code. 0.1, again it is 4 minus 2.2 whole square. And if we calculate from the calc, we get the value of the variance in the method number 1 is 1.36. So I've got this variance value. And in method number 2, again I'll be using the same variance formula, and pk is same, L bar is same, the difference is in Lk. So the Lk values which we obtained is 22233. So we'll remember this thing. I'll put all the values. 0.4, the first value we got was 2 minus 2.2 whole square plus 0.2, again it was 2 minus 2.2 whole square plus 0.2, 2 minus 2.2 whole square plus 0.1 probability, and the code was 3, code length is 3 minus 2.2 whole square plus 0.1, 3 minus 2.2 square. Now if I calculate this from calc, I get variance here as 0.16. So now I get the variance as 0.16. Now comparing in method 1 and method 2, the least the variance, the closer the values of the average length and the individual message code word length, the better the coding scheme. So here in method number 2, the variance is least, and so we say that the method number 2, in which the added probability is placed as highest as possible, is the best chosen method for doing or calculating the Huffman codes, is the best. So method 2 is best since variance is least. So the added probability should be placed as high as possible. So that was for today. I hope all the queries and doubts about Huffman coding might have been cleared by this video. And in case you have any other query or doubt, please drop the comment and I'll just come back to you with an answer. Till then, thank you, and subscribe and share as much as you can so that education should not stop. Thank you and have a good day.